So the first discrete structure that we're going to talk about is a set. And a set is defined as a well-defined, unordered collection of objects. So there's two words in this definition that we really need to get an understanding of. The first one is well-defined. What does it mean, well-defined? That tells me that given an object, I should tell whether or not it belongs in my set. Unordered means the order in which the objects appear doesn't matter. So for instance, let's say that I have a set of all the socks in my drawer. Well-defined means that I could pick a shoe up off the floor and decide if that shoe belongs in my set. And if the set is all the socks in my drawer, then a shoe most definitely does not belong. Unordered means it doesn't matter the order in which I were to list out all of the socks in my drawer, just so long as I get all of the elements in the set. And the objects are just the items that are making up my set. For instance, once again, I could have a collection of all the my socks in my drawer, or I could have the collection of all the shoes in my closet. I could have a collection of all the trees in the backyard, or all the students in this class, or as we talked about in class, all the vehicles in the parking lot. So let's get an example of what a set looks like. The notation for a set, I'm going to give the set a name. Generally, that would be a capital letter. And then I'm going to use some equal signs. I'm going to use the curly braces to enclose all of the elements in my set. And then I'm just going to start listing them all. Let's say, for instance, we're talking about the students in the class. Let's say, for instance, this is an incredibly small class and I only have 5 students. So set A includes all of the students in this class. I'm going to close it up with a closing curly brace. And this is an indication of a set. Let's create another one. B. Let's do all of the red cars in the parking lot. So there are 5 red vehicles in the parking lot. Now, just so you don't think that all sets have to have 5 elements in them, maybe I have a set C that contains letters of the alphabet, A, B, C, D, E, and then I'm going to use an ellipsis, X, Y, and Z. That would be a set that contains all letters of the alphabet. I could have another set that contains 1, 2, 3, 4, 5, 6, 7, and I'm going to skip 8 and just go directly to 9. It's going to be kind of a strange set. So I don't want you to think that sets have to have 5 elements. So speaking of the word element, I can determine if an object or an item is an element in a set by using this element symbol. It's kind of an elongated E, and it means an element of. The way that I would use it is kind of like asking a question. I could say that Sam is an element of set A. I can also say that Sam is not an element of set B, because when I look at set B, what I see in there is a bunch of red cars. I can say that A is an element in set C, and that 4 is an element in set D, but 4 is not an element in set A. And so this elongated E represents element of. It means, is it a member of, is it one of the elements in the set? Another thing that I might want to know about a set is how many elements it actually has. And so if I wanted to know how many elements set A has, I am going to surround the name of the set by pipes on either side, and this is going to be the cardinality. The cardinality just means how many elements are in it. So the cardinality of set A, if I count them up, Sam, Stacy, James, Kim, and Juan, there are 5 elements in it. What is the cardinality of set B? Jeep, Dodge, Chevy, Ford, and Camaro, there are also 5 elements in it, if I know how many letters there are in the alphabet. And the same with the cardinality of set D. We went 1 through 9, but I skipped 8, so I'm pretty sure that if I were to count those up, there would be 8 in total. I'm going to surround the name of the set by pipes, and that is going to be an indication of the number of elements that are in the set. All right, so remember when we defined a set as a well-defined, unordered collection of objects. That means unordered. So I'm going to give you an example of 2 sets, and we're going to see if the order in which the elements appear matters. So let's say, for instance, I have some set A, and then I have some set B. are these two sets equal? And given the fact that order does not matter, the only thing that matters is that the two sets contain the same elements, whether or not they are in the correct order, I can say that A and B are equivalent or equal sets. Another thing that we're going to find out is, let's say that I have some set C that contains 1, 1, 1, 2, 3, 3, 3, 4, and 5, and I have just begun dropping commas. My apologies for dropping those commas. Is this equivalent to 1, 2, 3, 4, and 5? I will not have repeating elements in a set. For instance, if I have a red Jeep in my parking lot, I'm not going to include that red Jeep multiple times in the same set. And so even though I have repeating elements in set C, I'm going to disregard all of those elements, and it actually will be equivalent with the second set, 1, 2, 3, 4, 5, because the repeating elements are disregarded. So hopefully this is all making sense. Let me know if you have any questions.